now we're going to talk about how we can visualize these bonds happening. And in order to do that, we're going to use the Lewis dot. We've already done a worksheet on Lewis dot, and remember, for our beryllium, this is our Bohr model, but we only care about these valence electrons now, so and our Lewis dot is only valence electrons. So reminder, where do we get that? That's our group number. Beryllium's group 2. It has 2 valence electrons. We draw our dots. You can pretend that this is a box. And we have 1, 2, 3, 4 sides. Keep going around the side until we double up. Okay? Our metals are cations. Why? Because we lose these 2 outside electrons to go down to our next shell. Remember, we want to try and get 8 around there, and that's our octet rule. Atoms want 8 electrons around them. We can either remove 2 to go down to our next full shell, or we could add 6. Well, it's easier to move 2 things than move 6 things, and we're lazy. So our Lewis dot for our cation, because it loses 2, we have to put it in brackets, and it has to have the charge right there on the outside, okay? Our nonmetals form anions. Why? Because they're getting very close to that full 8, so they gain, this is oxygen, it will gain 2 to form our oxygen anion, which has that -2 charge right there, okay? So remember, we need it in brackets. We need our charge on the outside, and we are trying to get a full 8. Our valence corresponds to the group number. So this is in 6A. It has 6 valence electrons. It would just take 2 more to make that full 8. Now we have these steps. I want you to write these steps. They're going to make way more sense to do it together. Okay, so you're going to add. When we start doing bonds with multiple atoms, you need to add up all the electrons that come to the party. That's the electron for every atom. Then you're going to bond the atoms around a central atom using a line. Okay, this line that you're going to use to bond is 2 electrons. Okay, that's our bond line. And we're going to place remaining electrons in pairs. Check for octet rule, so everything should have 8 around an atom. See, this has 8 for our ion, okay? But when we're bonding, you need to check everything for 8, but we have 3 exceptions, okay? We have hydrogen, boron in group 3, and then we have another one. Okay, we'll talk about that. If you don't have enough electrons to make 8 around every atom, we're going to share a pair. Okay, so here's just a quick example of methane. We have carbon, which has 4 valence hydrogens, which come with 1 valence electron. That's 8 valence electrons. We need a central atom, so you look for the one that we could circle atoms around. Carbon is always going to be our central atom. And then we have 4 hydrogens around there. We bond each hydrogen with a line. That line means 2 shared electrons. So I have 2, 4, 6, 8 electrons, and I have 8 valence electrons. I'm out. So here, if I look around my carbon, I have 2, 4, 6, 8. Around each hydrogen, I only have 2, and that's our exception. So our exceptions to the octet rule is hydrogen's happy with only 2 electrons. It will only ever have 2 electrons, okay? Hydrogen always looks like this, 1 bond line, that's it. Boron in group 3 is happy with 6 electrons. A period 3 and up could have an expanded octet, which means more than 8 electrons around the central atom, so you draw like a little there. And we are going to do some examples now.